Good morning. This is your Math Sensei, Mr. Spensei, and this is Star Test 2025 Algebra for problems 23 through, I believe it is 23 through 33. So it says, which expression is equivalent to 2k squared minus 3m times 3k minus 4? First off, I'm going to tell you, I always tell you if it's a really important problem. This is one I'd like you to know, but it doesn't fall into the most important category. But first off, we're going to look for shortcuts to eliminating some answers. So first off, if I just take the 2 times 3, I get 6. Well, guess what? We can do that every single time, and that eliminates two answers. But that's about as far as we can go. We can also take the last one. So the first times the first and the last times the last. Well, negative times a negative is a positive, and 3 times 4 is 12. But both of these have 12. So that kind of takes care of all the shortcuts. But at this point, we have a 50% chance of guessing. Now, the way to approach this problem is I'm going to take this first term and multiply it by everything here. Well, we already said 2 times 3 is 6. And I have an exponent of 1 here. So this is k squared plus 1. So this is actually 6k cubed. Now I have to take this 2k and multiply it by 4. And 2 times 4, it gives me negative 8. This doesn't have a k, so we just copy the k squared. So this is minus 8k squared. We should be seeing what our answer is by now. It looks like it's going to be this one, but we have to continue on. And now we take this negative 3m and multiply it by that, and we end up with 3mk. And then I multiply it times this, and a negative 3 times a negative 4 is a positive 12m. Well, at this point, it's clear that our answer choice is C. Once again, I'd like you to know it, not the most critical one. This one is a little more critical. All right. It's not a have to know, but you ought to know it. Okay. This is one you should get right, but it's not in the have to category. First off, we have a system of linear equations. Well, they want us to compare the linear equations, which means I need to put them into y equals mx plus b format. Well, this one is y equals mx plus b. Got to remember, m is our slope, that's our rate, and b is our y-intercept. So I need to put this equation in slope-intercept form. So I'm going to copy it over and write 3x plus 6y equals 24. And putting things into slope-intercept form is one of the most important skills you can do. So I need to move this. I need to get the y by itself. And to do that, I need to move this 3x. Well, this is a plus 3x, so I need to do a minus 3x. This goes away, and now I have 6y equals negative 3x plus 24. These two are side by side, so I have to divide to separate them. And I divide everything by that, and this becomes y equals, and I'm just going to turn this into a decimal. I'll show you on the calculator. Negative 3 divided by 6 is negative 0.5. And I copy the x down. And then 24 divided by 6 gives me 4. So plus 4. Well, we already had this one up here, and I'm going to copy it down as well. We already had y equals negative 0.5x plus 4. When I look at those, they both have the same slope and the same y-intercept, which means they're the same line. So let's look at our answer choices. The system has no solutions. Okay, to be no solutions, you have to have parallel lines, which means same slope, but different y-intercepts. Well, we have the same slope, but we have the same y-intercept, so it can't be that. These are not parallel lines. And we're going to check this out on Desmos in a moment. We're going to plug both of these in. The system has exactly one solution. That means in this case, we'd have to have different slopes. We don't have different slopes, so it can't be this one. The system has two equations. Two, if they're linear, this is not possible. This is not possible. Now, if it's a quadratic, it's possible, but not with a linear. So this is not possible. The system has infinitely many. To be infinitely many, they have to be the same line, which means same slope and same y-intercept. Well, in this case, it looks like we have that. Now, so this looks like this is our answer, but I'm going to plug both these into Desmos so that you can see how you can check yourself out. So we're going to go to share and plugging in the first one, the one I hadn't read, y equals negative 0.5x plus 4. All right, so there's the first one. Now we're going to see if this other equation lies directly on top of it, which it will. Y equals negative 0.5x plus 4. And the red line went away because the blue line lay directly on top of it. There's the red, the blue lies on top of it. They're exactly the same line. If they're the same line, they're touching everywhere. They're touching at every single point. So there's infinitely many solutions. That means they touch at every point. Number 25, without even reading this, I know I have a table, which means this is a Desmos problem because I'm going to need to put this table into Desmos. So a restaurant owner experimented with different prices, and here we go. Based on the line of best fit. So we're looking for a line. So this is going to be linear because we see the word line. Which predictions are true? And we're supposed to select two correct answers. Well, this problem is one you need to get right. You should get right, but it does require a little bit of work. It's going to require a little bit of trial and error. Well, the very first thing is since we have a table, we know we're going to have to input this table into Desmos. So let's go ahead and get that going because that's going to take me a moment to get done. So I'm sharing my screen. I'm going to clear out this last problem we just did. Remember, we press the plus button and then select table. And we have 6.50, 9.50, 7.25, 11, 8.75. Oops. Always make sure that you get your numbers in correctly. Otherwise, it doesn't work very well. 9.35. And on the Y, we have 107, 78, 99, 65, 87, and 80. So now that I have it in, I'm going to hit the little domino button. I want it to say linear, and it does. And I get this equation. Now, I'm going to tell you this is an ugly equation. I'm going to write it down on my paper, and I'm going to go ahead and put parentheses around the x. Okay, makes a big difference if you put, because we're going to substitute in for x here in a moment, and I'll show you in just a moment what we're going to do. I'm going to write that equation on my paper. Don't have a whole lot of room for it, but I have y equals negative 9.2976 parentheses x plus 167.12. I'll just stop it right there. Okay, so I have that. So I know what my equation is. So I have my linear equation. And it says approximately 82 lunch specials would be sold if the price were $5. Well, this is my x and this is my y. So that means I need to plug in 5 for x, 6 for x, 750 for x. When I plug in 5, I want to get something close to 82. Now it says approximately, it doesn't say exactly. So we're looking for approximately those numbers. So we'll plug in these values right here. We're going to plug those in and see which ones get me close to these values. Now we're supposed to select two answers. That means there's going to be more than one. So I'm going to go back over to Desmos and start plugging in 650 and see if I get 107 or how close I get to it. So I'm going to go back to that share screen. And once again, this is a problem you need to get right. It's a lot of work, but it's one you can definitely get right. So In place of the X, I'm going to type in 650, and I'm going to hope that I get the 107. Hey, you know what? 650 gets me pretty close. So I'm going to write that down. That looks, oh, you know what? I wasn't supposed to plug in 650. I was supposed to plug in $5. I'm sorry about that. $5 was the first answer choice, so I plug in five. And when I plug in five, I end up getting 120.6. I'm going to write that down, but that doesn't look that close. I don't think it's A. So then the next one was $6. I plug in six and I get 111.33. You know what? That's pretty close. So I think B is one of my answer choices. But remember, I need two. So I keep going and I'm going to go ahead and try 750. 7.50. When I do that, I get 97. Well, 97.3 is not that close to the 102, so I don't think it's C. Then I'm going to go try 1250. And we get 50.9. Well, 50.9 is definitely not close to 74. So I'm hoping it's going to be E. So we need to plug in $15. When we plug in 15 and we get 27.6. You know what? 27.6 would round up to 28. That's pretty close. So I'm going to close my screen and look back at what we had. So when I plugged in five, I got 120. That's not close to 82. So that didn't work. I plugged in six and I got 111.3. That's pretty close. I like this one. I plugged in 750. I got 97. That's not close to 102, so not right. I plugged in 1250. I got 50. That's nowhere near 74. I plugged in 15, and that's just a little bit below 28. I got 27.6. That's pretty close. B and E are my closest, so that's my answer to that problem. So B and E to number 25. Moving on to number 26. Number 26 appears to be a scary question, but it's simple. It's easy. You got to get this one right. So the equation x times x plus 3 equals 108 can be used to find the width, which is x. Oh, so they're telling me this right here is my width of a rectangular deck that has an area of 108 square feet. What is the width of the deck in feet? Well, guess what? All I have to remember is the way Desmos work. So I'm going to write down this x parentheses x plus 3 equals 108. Now, what I'd like to do is plug this directly into Desmos, but it doesn't like that. So anytime we have variables like this and we're trying to solve, when we're trying to solve for something, we replace the x with an n, and we replace the equal with a squiggle. And this should give us our answer. So we're going to move back over to our share screen. And let's get rid of this last problem. And let's type that in. N parentheses n plus 3. Not the equals, but the squiggle. And then 108. When we do that, we end up getting n equals 9. All right, I'm going to stop my share. And we have n equals 9. Guess what? That's right here. So the answer choice number 26 is C. This is one you have to get right. Next thing, we have a table. If we have a table, we know we're going to Desmos. We're going to input the entire table, and it asks for the slope of the line. The fact that we have a line or that it says linear means we have y equals mx plus b. M is our slope, and b is our y-intercept. Okay, so we're looking for our slope, so we're going to be looking for m. So I'm going to input this table, and I'm going to see which gives me my answer. So I'm going to go over to the share screen. And I'm going to clear out our last problem. I'm also going to try to get the lights back on in here. Come on, lights. There we go. And next thing I'm going to do is I'm going to put the plus button. The plus button gives me a table. And we have -4, -1, 2, and 5. And then we have 23, 15, 7, and then -1. All right, as soon as we do that, we're gonna hit the domino button. And there's our equation. Y equals, and I'm gonna write this down. Y equals negative 2.667 x plus 12.33. Let me go ahead and line that up with my answers. So first off, we know we want y equals mx plus b. And we know m is our slope, so this is our slope. So we have a negative. Well, that tells me it can't be this one, and it can't be this one. Unfortunately, Desmos doesn't, they always give us decimals, and the test always gives us fractions. So I have to do a little bit of work. Not much. I need to take my calculator out and go -8 divided by 3. When I do that, this equals negative 2.667. That matches, so this is my answer. But just to do the last one, we'll -3 divided by 8, and we get -0.375 equals -0.375, and that is incorrect. Okay, number 28. This is one I'd like you to know, but it's not as required. However, let's look at this first part, 2/6. Can that be reduced? So let's take our calculator, 2 divided by 6. And if I go math, enter, I get 1/3. I'm also going to show you that on the calculator, on Desmos. So I can drag this down, and I know that this is going to be 1/3. Because all I did was reduce that first part. I didn't change anything else. So now we have x to the 12th and x to the -3. So hold on for just a moment. I want to show you on Desmos that we can go ahead and reduce on Desmos. So I'm going to share that screen. I'm going to put in that fraction. We had 2/6. And if I hit the fraction button, there's 1/3. So we can definitely do that on Desmos. Now, I hate negative exponents. It doesn't matter to me where the negative exponent appears. I always move it to make it positive. So if it's in the bottom, I move it to the top. If it's in the top, I move it to the bottom. So I'm going to rewrite this. And I'm going to rewrite it as x to the 12th x cubed. Because I just moved, this was negative, so I moved this whole thing up to the top. Well, the weird thing is when you're multiplying, you add exponents. So now we have 1/3 x to the 12th plus 3 equals 1/3. 12 plus 3 is 15. So initially we clicked on this and we drug it down. Now we're going to click on this box and drag it down over here. All right, so that's the answer to 28. Number 29. Number 29 is a give me problem. But Mr. Spencer, it's got fractions and letters, etc. It's like, yeah, this is one it's a Desmos problem. It's a piece of cake. And while I'd like to plug it into Desmos just like this, I told you before, Desmos doesn't like the variables and it doesn't like the equals. So we're going to have to change this to 4/3 n, we change the z to an n, plus 6 equals, except we can't use equal, we have to use the squiggle. Even I forget sometimes, equals the squiggle. And then we have a -4 parenthesis 1/6 n plus 9. So I'm going to plug this into Desmos and see if we can't get an answer. Okay? So I'm going to go to my share screen. At least I say I'm going to my share screen. Maybe I'm lying. It would be the first time. Hopefully it'll be the last time. So we have 4/3 parenthesis. Oh, no parenthesis. N plus 6 squiggle -4 parenthesis 1/6 plus 9. Okay, at this point, we ended up getting n equals negative 21. So I'm going to stop my share. That's what it gave me on my screen. It said n equals negative 21. And guess what? That means 29 was B. Easy problem. We just had to follow the Desmos. Okay, number 30. What is the solution set for the inequality y is greater than 5x minus 3? All right. Well, first off, there's a couple things we have to know. Super important. We can get points just by knowing this. If I have one of these symbols, it's a dashed line. If I have one of those symbols, it's a solid line. Well, in this case, I have a dashed line. So when it says solid or dashed, I'm going to select dashed. Okay. Now, how do I say that? Do I say less than or do I say greater than? It's like, oh, that's a greater. Well, let me ask you, is greater above or below the line? Well, greater is above, so I'm going to just, because that's more, because greater is above, so it's more. You're like, well, but you still haven't graphed that. No, I haven't yet. I'm going to rewrite that equation because I'm going to go to Desmos and go y equal 5x minus 3 because I'm going to show you how to do this on the test. We're going to go ahead and get rid of it. Desmos will not like this, but it'll like the equal sign. So we're going to go to Desmos and on the share screen and type in y equals 5x minus 3, and we're going to get a couple points. So here we go. Y equals 5x minus 3. Now, I'm going to get a couple points and a couple of easy points that I see. I see that point. That's an easy one. Let's see if we can get a better point. Well, 0 and 0.6, that'll work. We'll take that one. And then we'll take this one right here, 0, negative 3. And we'll have that one also labeled. Okay, so we know we have negative 3, and we're going to also look at the way you graph that line, because this is another problem we need to get right. I'm going to write those points down. 0.6 and 0, and 0 and negative 3. And that's my X, and that's my Y for both of them. And I'm going to stop my share, and we're going to go back. So what I would do on the test is I'd go, hey, you know what? I'm going to graph these points. I'm going to go 0, negative 3, and it'll plot that point. Then I'm going to put in 0.60, which is about here, and I'll plot that point. And at that point, Desmos will connect and it'll connect it, and you selected a dashed line, so you should be able to get a dashed line for it to draw you a dashed line, and then you're going to click solution, you'll shade above. But I want to show you one other thing. I can count this out because this is a fraction. It's 5 over 1. So up 1, 2, 3, 4, 5, and over 1. So there's another point. If we needed it, we'll connect those 2 points. But remember, we said it was a dashed line, so we want to make sure it's a dashed line. And we're shading above, which is right here. And that would be the answer. Now, couple things about this. This is a really important question that you need to get right. Okay, if you have questions about it, see me. Next one, it says, which equation is equivalent to 5x minus 8y equals 40 when solved for y? So in this case, we see these are all in y equals mx plus b. So we want to solve it for y. We want it y equals mx plus b format. So we have 5x minus 8y equals 40. I can't tell you, this shows up so many times in so many different ways. We want to solve for y. We start off by moving the x's. We do whatever the opposite is. Well, this is a plus 5x, so the opposite of a plus 5x is a minus 5x. This goes away. And now we have negative 8y equals negative 5x plus 40. Okay, I need to separate that number from the y. When I'm trying to separate, that means I'm dividing. So I'm dividing by -8, and I'm dividing everything by -8. And I should get y equals, and a negative divided by a negative on your calculator would be 5/8 x. 40 divided by -8 is -5. So we have a 5/8 and a -5. Our answer choice to 31 is D. '32. Part of a quadratic function is shown on a grid. Which statement must best represent the domain part of the function? You have to know. This is one you have to know. Domain is the x's. Okay? So that means I'm going to put an x on the x-axis, and I'm going to draw a line and the number. Well, this is a 5. This is an arrow. Arrow is not a number. That's the infinity sign. So basically, my domain is infinity less than x less than or equal to 5. We never worry about this. We never worry about the infinity. We can scratch that out. And so we have x is less than 5. So all real numbers less than or equal to 5. X is less than or equal to 5. That looks good. Let's keep reading. All real numbers greater than or equal to 3? No. All real numbers greater than or equal to 1? No. All real numbers? Nope, because we don't have any numbers greater than 5. Remember, you always draw to the x-axis. So this one is A. Now, they didn't ask this, but if they had asked for the range, remember the range is the y. So I would label the y-axis, and I would start at the bottom, and I go, okay, because we always want to go smallest to greatest, 1, and once again, we have infinity. So we'd go 1, y, and infinity. And this case, y is greater than all numbers, y is greater than 1. Okay, because we never mess with the infinity part. Once we have it, we go, okay, we can get rid of it. Y is greater than or equal to 1, and you can rewrite it as that. Okay, last one. Graph the function 6 1/3 to the x. Anytime you see something raised to the x, this is an exponential. You have to know that it's an exponential. And remember, there is a formula chart attached to your test. This is the formula is going to look like y equals a times b to the x. And every time I do one of these, I take a moment and do some teaching. First off, it says exponential. We know this. We know that part. The next thing, a is the y-intercept. It's also the beginning. All right. So we know it's going to start at 6. I already know that. I know that because that's a, because I can put y equals a times b raised to the x. B, if it's greater than 1, we have growth, and the graph goes up, and the graph will look like this. But in this case, if we have b is less than 1, we have decay, and it goes down, and the graph looks like this. That's the one going up. This is the one going down. Well, when I look at that, I have 1/3. And I'm going to take my calculator, and I'm going to go 1 divided by 3, and I get 0.33. Well, 0.33 is less than 1. 33 cents is less than $1. So this means I have decay. It's going down. So I'm going to end up with something that looks like this. I also know this. For every time I do one of these, I've never seen a star test that didn't have y equals 0 for the asymptote. So there's one other thing that's really good news. If you forgot all that information, now you need to know that because there's going to be probably 5 problems that are on exponentials on the star test. But I need you to know this. We can still plug this into so you need to know all those definitions. But I can plug this into Desmos, and let's see what happens. So we're going to plug in the Desmos and see if we can't get that graph. And on your star test, you will have to play around with it a little bit, but you will be able to slide it around into place. It's not that hard. It just take a moment of practice. So y equals 6 parentheses 1/3. Oops. And put the typewriter button at the bottom and use the X button. And we have, there it is. There's our y-intercept. I'm going to go ahead and label that because we already know that that's going to be there. And I'm going to find another good point. And right here is another good point at basically at 1 and 2. So I'm going to stop my share and I'm going to go, you know what? At 1 and 2, I have a good point. And my asymptote is y equals 0. So my graph is going to look something like this. And remember, we knew it was going down, and we knew it was going down because of it was decay because b was less than 1. The 33 was less than 1. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.